Today in this class we will discuss about the overload protection of transmission lines. So let us see, first discuss the figure. What is the construction of the figure which is applied for the protection of transmission lines? So as we can see here, this is a three-phase system where a circuit breaker is mounted across the all faces, that is R, Y and B, and in all faces there are CTs mounted. These CTs in R phase, Y phase and B phase, and further one end of these CTs are connected to this operating coil, where this operating coil is connected with the plunger in all three phases. Just see, this is CT. One end is common to all CTs and other end is connected to the three operating coils. These are the operating coils, and all the three operating coils are connected with the plunger, where this plunger connected with the operating contacts mechanism, which closes these contacts or the open these contacts. Now there is a trip coil. This trip coil is connected with the battery, DC battery. So this DC battery gives the supply to this trip coil, and other end is connected to this common circuit. So what will happen in normal operating condition, when there is no fault, so all the three phases R, Y and B, there is a normal current flowing, and these three CTs which are connected to this operating coil, so they remains balanced. It means the entering current at one CT at one end is equal to leaving the current at the opposite end. So what will happen, that in normal condition there is no any current circulated with these operating coils. Hence once this operating coils remains unoperated, so nothing happens to the trip coil and the circuit breakers remain closed. So all three phases will continue to supply the load current. Now we'll consider, let us say some fault happens across the loads or in the phases. In any phase, we can assume in any phase there may be a fault, or fault may be towards the load side. So what will happen, if there is any fault created in the load side or in the phases, so the current leaving or entering in all three CTs will not be equal. It means there will be unbalanced current which will be flowing through these CTs. So because of the unbalanced current in three CTs, there will be a unbalanced current which will be flowing in operating coil, and if any of the operating coil gets operated, it's not necessary that all the three operating coils should operate. If any of the operating coil gets operated, so what will happen, battery supply, this positive supply which is waiting here, let us say this operating coil operates, so positive supply which is waiting here, and by operating this operating coil the plunger will gets closed, so this contacts will close, so this supply will be extended through this circuit and it will come to the trip coil, then from trip coil it come to the negative side. It means the current is flowing to the trip coil, and as soon as the trip coil gets operated or attain a set value of the trip coil, that is trip coil is set for a particular current at which this will operate. So as soon as trip coil operates, these contacts which are closed now in R, Y and B phases will become open. So what will happen? All the three feeders will be disconnected from the load side. It means the faulty point will be isolated from the all the three feeders. So this may happen because of the overloading at any phase. Because as we know that if there is a fault, increase in current will be fed to the fault. So let me be the three-phase fault or a single-phase fault. For the all phases, for the all types of fault, this system will work, and as soon as the CT senses the fault current, so trip coil gets operated and these circuit breaker contacts will open. So these all phases will be disconnected immediately from the load or the faulty point. That is how the overload protection for the transmission line is provided. A similar protection for the transmission line is also provided, that is called the Translay system. So we have discussed here this circuit diagram, and let us go back. Same thing is explained here. The three CTs are mounted, one on each face of the feeder, and are connected across the three relay coils. In case of overloading, the solenoid plunger system of the relays operate to close the trip coil circuit, which in turn opens the circuit breaker, thereby disconnecting the protected feeder. The relays need readjustment or even replacement whenever a change in the system is made. The operation times are generally large. So this is the same thing has been described here, whatever I have explained in this circuit diagram for the overload protection of the transmission line. Now we are talking about the similar overload protection, that is called the Translay protection system. This Translay protection system is similar to the induction time overcurrent relay protection. So let us first discuss the circuit diagram, the Translay protection system, that is what is the design of this system. This system has been shown for the single phase system, but however we can provide this protection for the three phase system also. So this is the design of a Translay protection system. What we see here, similar to the overcurrent relay, induction type overcurrent relay, this disc is mounted between this upper magnet and the lower magnet. Similarly here also another Translay system is given, where again same disc is mounted between the two magnets, and this disc once rotate, this plunger will also have a rotation. So these are the trip coil connection. So once this trip coil connection gets closed, then circuit will be extended to the trip device. So similar construction as this Translay is replicates this Translay system, and both systems are connected together. So how it is connected? Let us see. The CT1 and CT2 they are mounted in the feeder. We are considering here it is a single phase feeder. So CT1 is mounted on the feeder, and for this relay CT2 is mounted on the feeder. Further, this CT1 and this CT2 are connected to the coils 1 and 1 dash. 1 is in this relay Translay system and 1 dash in other Translay system. Then the induction of the relay 1 and 1 dash will affect the induction in the 2 and 2 dash. So 2 and 2 dash coils, they are just mounted below the 1 and 1 dash coil. And further, these 2 and 2 dash connections are in phase opposition, and also they are connected with the coils 4 and 4 dash, which are in series. Let us verify the circuit connection. Let us see, this is the 4 and this is 4 dash coil. So a connection at lower end of the 2 coil is coming here. It is going to one side of the 4 coil and coming out from other end of the 4 coil. Then it goes back to the 4 dash of the another translay coil at lower magnet, then comes to the another end of the coil and goes back to the lower end of the 2 dash relay. So what we see that 4 and 4 dash both are connected in series and both are connected with 2 and 2 dash coil. But we see that 2 and 2 dash coils, they are connected in a such way that they are in phase opposition to each other. So what is the effect of this? That if there is any fault in the feeder, whether it is a single phase fault or the 3-phase fault. But here we are discussing only for the single phase system, because we have shown a circuit for the single phase Translay system. So in normal case, when there is no fault, then CT1 and CT2, they induces an EMF in the 1 and 1 dash coil. So there will be equal EMF induced in the coil 1 and 1 dash, and in turn they will ensure a current in 2 and 2 dash. But since 2 and 2 dash are in phase opposition, so the operating coils, that is 4 and 4 dash, they are the operating coil. A very small or negligible current will flow through these coils, that is a 4 and 4 dash coil. So this disc will not move. Both the discs will not move in normal situation. But whenever there is a fault in the system, that is single phase fault, then there will be an increase in current in this feeder. So there will be increase of sensing current through CT1 and CT2, and its effect will be in the coil 1 and 1 dash. So what will happen? This earlier the 2 and 2 dash were in phase opposition, so they were neutralizing the current flow in the operating coil. But now since fault is created, so excess current flowing through the single phase feeder will now increase, and accordingly once the increase in the current through 4 and 4 dash coil will reach to the set value of this operating current, then this 4 and 4 dash coil gets operated and this disc will start rotating. Both the disc will start rotating. So as soon as these contacts gets closes, a trip command is issued to the production system and circuit breaker isolate the faulty load or the faulty point. So that particular feeder is disconnected from the faulty circuit. So this is what the explanation of the Translay production system. Let us say once again describe what is this Translay system. In Translay system, the system works as a induction type overcurrent relay, and this system is also designed for the overcurrent protection of the transmission line. So in this system we have two CTs, CT1 and CT2. Both are connected with the relays 1 and 1 dash. So there will be induction effect from CT1 and CT2, and this induction effect will induce a voltage in 1 and 1 dash coil, and its effect will be also observed in the adjacent coils which are connected just below the 1 and 1 dash coil, that is called the 2 and 2 dash coil in the both relays. So in normal case, when there is no fault in the circuit, so a normal current entering through CT1 at one end and going to other end in the both CT1 and CT2, so there will not be any effective current which will be flowing through 2 and 2 dash coil to the 4 and 4 dash coil, because until unless the required current is not flowing in the 4 and 4 dash coil, this relay, that is this disc, will not operate, because the 4 and 4 dash coil are called the operating coil. Whenever there is a fault in the circuit, then increase in the current in 4 and 4 dash coil will try to rotate the disc, and this plunger gets closed in both the relays. So a trip command will be issued to disconnect the faulty feeder. That is how this system will operate. Here we see that this 4 and 4 dash coil, they are connected in series with the help of pilot wires. Here there is a use of pilot wires. So let us go back in the starting of this relay, that is called the Translay production system. So what it is written here, this system is based on the established principle of the current entering at one end of the feeder being equal at any instant to that of leaving at the other end. A simple form of Translay production for a single phase feeder is shown in figure. Already you have seen. Under healthy conditions, the line current transformers CT1 and CT2 at opposite ends of the feeder carry equal currents, and therefore the coils 1 and 1 dash connected to them induce equal EMF in the winding 2 and 2 dash respectively. Now since the winding 2 and 2 dash are connected in opposition by means of a pilot wires with the operating coil 4 and 4 dash in series with them, so no forward torque is exerted on the disc. When a fault occurs, the current through one CT is greater than that of other, so a small current circulates through the operating coils and pilot wires, and when it attains the preset value, the relay is caused to close the tripping circuit and thus disconnect the faulty feeder. So the trans relay implied is quite similar in construction to an overcurrent induction type relay. So this is all about the overload protection system, in which we have discussed here first a normal overload protection system of transmission line, where 3 coils are connected one by one in each phase, and a trip coil is connected with the battery supply. So whenever there is an increase in the CT current, the excess current circulates in the operating coil, and operating coil operates a plunger, so a battery supply is extended to the trip coil, and once the trip coil operates, the circuit breaker contacts gets open, so feeders are disconnected from the faulty point or the faulty load. And similar protection, that is the Translay protection system, has been shown here. So there are two relays, two similar relays are mounted here in phase opposition, we can say, but the system is shown for the single phase. However, the same system can be applied for the three phase feeder also. So in this case, as we have seen discussed, that CT1 and CT2, they are connected in feeder and their effect is induced in 2 and 2 days. There will be equal EMF will be induced in the 2 and 2 days, but since 2 and 2 days both they are connected in phase opposition and also they are connected in series with the 4 and 4 days, so very little or negligible current is flowing in the 4 and 4 days. Hence, these disc will not operate or the torque will not be sufficient to rotate these discs. But as soon as there is a extra current flowing because of the fault, then increase in current to the operating coil 4 and 4 days will try to rotate the disc, so the contacts will close, and once these contacts are closed, then this will be extended to the protection system to trip the feeder from the fault point. So that is what has been described in the system. So this is overall about the overload protection of the transmission lines.